Aerogel, the world's lightest, that is least dense solid. This piece has a mass of just 1.22 grams. That is only a few times the mass of the same volume of air, which kind of makes sense because it is 99.8% air. In fact, some aerogels are so light that if you removed all the air from them, they would be less dense than air. I have long been fascinated by aerogel, so I actually flew out to Aerogel Technologies in Boston to find out, why was aerogel invented? How is it made? Why is it such a good thermal insulator? And what is it used for? Okay, we are going to try an experiment to demonstrate the insulating power of aerogel. So over here we have two setups, one with a glass petri dish and the other one with aerogel on top. Both are made of silica, but with very different physical structures. We're gonna see how long it takes to melt these chocolate bunnies with a Bunsen burner. Now to have a look at this experiment, we have a Fleur T1020, which can see temperatures up to 2000 degrees Celsius.
It's getting pretty hot.
Yeah, you can see that the glass is getting really hot already. And after just a minute,
It's starting to smoke.
oh, okay.
It's definitely melting and smoking. Oh yeah, here we go. I would say that that's a phase change.
We've got a liquid chocolate situation. We have some smoking bunny. Over here, the bunny is actually sort of melting over, and look, it's sort of tilting to the side.
All right, I think we're gonna call that a melt.
What is that?
Oh, on cue, on cue. I would say that that's a material fail.
Not only did the bunny melt quickly, the petri dish cracked under the thermal expansion.
Want to pop it in?
So now let's try the aerogel.
Okay. All right.
So how was aerogel invented?
Back in 1931, a guy named Professor Samuel Kistler had a bet with his colleague, Charles Learned.
Now the bet revolved around jellies, like peanut butter and jelly jellies. Now the thing about jellies is they are actually a combination of liquids and solids. I mean, they're mostly liquid, but it's embedded within this 3D solid structure.
So if you think of a gel like Jell-O, has a skeleton with nano-sized pores that gives it its rigidity, and then that's about 1% of the gel.
So the bet was this: could you remove the liquid from the jelly without affecting the solid structure? I mean, if you just evaporate the liquid out, well, then the solid structure shrinks, because as you remove liquid molecules, they pull on each other and they pull on the solid structure around them, basically crumpling it from the inside. Now, Samuel Kistler solved this problem in two ways. First, he realized you could replace